Okay, when you simplify radicals, simplifying radicals has to do with imperfect radicals. Those are radicals that don't have square roots or perfect square roots. So these are like radicals that have like the square root of 48. Okay, this is not a perfect square root. Okay, so you must make a factor tree. Okay, something else that you should know is that this is called a radical. The square root sign is also called a radical. And whatever's inside of it, like 48, whatever's inside is called a radicand. Okay, because this is not a perfect square root, we're going to make a factor tree. So you can factor this 6 times 8, and then you can factor it, so 6 times 3, those are, I'm sorry, 2 times 3, those are prime numbers, and then 2 times 4, and then 2 times 2. And then we're going to circle all the prime numbers. Okay, here's the story about the dates. Okay, you have to picture it like this is the house. Okay, your radical is the house. So when you simplify, you're going to pick out pairs, okay, or dates, because whatever is in common, like 2 and 2 is in common, so this is a pair. So each pair can go on a date and come outside of the house. So I have a pair of 2s, so I'm going to write 2, because that 2 represents a pair. I have another pair of 2s, okay? The other pair of 2s can come out, and this represents another pair of 2s. Okay, so for each pair that you write, you're only going to write one number, because when you go on a date, you only go in one car. So it just represents 1. So your pair, each pair that comes out of the house represents 1. You're going to put 1, 2, and the other 2. So that represents 2 pairs. Okay, the number or the prime number that does not have a date is 3. Okay, 3 has no date. So it's going to be all lonely and stuck in the house because he has no date. So the numbers that you have on the outside, you're going to multiply together. So this means you have 4 square roots of 3. And that's your simplified version of the square root of 48. So whether you put the square root of 48 in your calculator or 4 times the square root of 3, either way you're going to come up with the same number, because this represents the square root of 48. Okay, so if you have something that's not a perfect square root, if you look at it and you say, hey, this is an even number, the first thing that you should do is divide by 2. So you would figure out, okay, 2 is going to be one of my prime numbers, and then 2 times 64, well, that equals 128. So then you can break it down by 8s, and then 2 and 4, and 2 and 2. And we are only circling the prime numbers. You're not going to circle 4. You're not going to circle 8. You're only circling the prime numbers. 1 pair of 2s that comes outside. Then I got another pair that can come outside. Then I have another pair that can come outside. Okay. And then I have 1 lonely 2 that has no date that has to stay inside. Okay. The rest of the numbers that are on the outside that represent each pair have to be multiplied together. So 2 times 2 is 4 times 2, so 8 square roots of 2. I want you guys to check that and make sure it's simplified. So you're going to put square root of 128 in your calculators and then put 8 square roots of 2. And this is the same thing as saying 8 times the square root of 2. So you're going to put that in your calculator and make sure that they equal each other. Okay, so if you have 3 square roots of 50, the first thing that you're going to do is simplify the radical. That means you're going to simplify what's in here. So 5 times 10, and then 2 times 5. So all of these are prime. I do have a pair, okay? I have a pair of 5s that could come out, and 2 stays inside. But I also have to not forget that I already had that 3 on the outside, so I have to bring it down and multiply by the other outside number. So I'm going to multiply the 2 coefficients, which that's the number in front. So I have 15 square roots of 2, and that's simplified. So next we're going to talk about simplifying with variables. When you're simplifying with variables, you're going to pull out the pairs based on the exponent. Okay, say for instance we have x to the 7th power as our radicand, and that's whatever is in the square root. Okay, we are going to pull out the pairs. So you have to think about how many pairs are in 7. So we can look at it like x times x times x times x times x times x times x. So here I have 7 x's. So I'm going to pull out each pair. So I have a pair of x's, a pair of x's, and a pair of x's. And all of these can come out of the radical. So I have 1, 2, 3 pairs. So when I simplify the square root of x to the 7th power, for each pair, which is 3 pairs, I'm going to pull that out. So I have 3 pairs, so I'm going to put x to the 3rd on the outside, and I have 1 pair left over, or excuse me, I have 1 left over, not a pair, but this is going to go inside the radical because it has no pair. So this would be the most simplified version. Okay, for my next example, I have the radical of 128x to the 3rd power. So 128 is not a perfect square root, so I know I'm going to have to break that down first. So when I break this down, I'm going to divide by 2. So I have 2 times 64, and I can even break that down further. 8 times 8, 2 times 4, 2 times 4, 2 times 2, 2 times 2. Okay, and then I'm going to go back and I'm going to circle all of my prime numbers. So 2, 2, 2, 2, so all of these 2's. Okay, then I'm going to look at these and see how many pairs of 2's do I have. So I have 1 pair of 2's, another pair of 2's, another pair of 2's, and then I have 1 2 that is left over that does not have a pair. So that is going to stay in the radical, and my other 3 pairs of 2's can come out. So for each pair, I'm going to represent that with 1 2. So this is 1 pair of 2's, this is 2 pair of 2's, and this is 3 pairs of 2's. So I'm going to multiply all of these together. So I have 8 pairs of 2's. Okay, and that simplifies the 128. Now I have to go back through and say, okay, how many pairs of x's are in x to the 3rd? Well, if you think about this like x times x times x, then you'll realize that you have 1 pair of x's. So the 1 pair of x's can also come out. And we're going to write that next to our 8 because it's out. And then I have another x that has no pair, so it's going to stay in with the 2. So the simplified version would be 8x square root of 2x. Okay, for my next example, I have 2 square roots of 75x to the third and y to the fourth. So I know that this is my coefficient that I'm going to have to multiply at the very end. So anything that's on the outside at the very end, I'm still going to have to multiply. So I'm actually going to go ahead and underline this so that I remember to multiply it. Okay, and then I look at this like these are 3 separate parts of my problem. I have 75. That's an imperfect square root, so I'm going to have to simplify that. Then I have x to the third, so I'll have to pull out the pair of x's. Okay, then I have x to the fourth, so I'll have to pull out pairs of, or not x to the fourth, y to the fourth, so I'll have to pull out pairs of y's. Okay, so I can go ahead and my first step will be to simplify. So I'm going to simplify the 75. So I know that 3 times 25 gives me 75. 3 is prime, and then 25 can be broken down until 5 times 5. Okay, and I know I have a pair of these 5s, so my 5 can come out. And what's left inside is going to be the 3. Okay, now I'm looking at the x to the third power. Well, how many x's are in x to the third power? How many pairs do I have? I have 1 pair. So this pair of x's can come out. So I'm going to go ahead and write that on the outside because it can come out. But I have this 1 x left over, so it's going to stay inside. Okay, now I'm going to look at the y. With the y, I have 1, 2, 3, 4 y's, and that means I have 2 pairs. Plus, this is an even number, okay? So your pairs is going to be even, so you won't have any y's left over to go in the radical. So this will also come outside. So these are 2 pairs, so you'll put y squared. And this is going to come out, and it's going to come over here. And I don't have enough room, so I'm going to write it lower. So 5x, and then y to the second power, because I have 2 pairs. And then in the radical, I have 3x, because 3x is what was left over that did not have a pair. Well, what can I not forget? I can't forget this 2 up here. Okay, this guy has to come down and be multiplied as well. So I have 2 times 5. Well, I can multiply the 2 and the 5 together. So my final answer would be 10xy squared, and then in the radical there would be a 3x. And this would be the most simplified version. Okay? So you always have to keep in mind that this number on the outside you're going to multiply at the very end. You have to simplify the 75 first. Then you have to pull out the pairs of the variables that you have. Anything left over goes inside the radical. Okay, for my next example, I have 6 square roots of 45x to the 5th and y to the 7th. Okay, so I'm going to underline that 6 because I'm going to use it later because I'm going to multiply at the end by my other outside number. With 45, you're going to simplify that because it's not a perfect square root. So you have 5 times 9, which 5 is prime, and then 9 goes 3 times 3. Okay, so my 3's will come out, and my 5 will stay inside because it doesn't have a pair. Now I can go ahead and figure out how many x's that I can pull out pairs of and how many y's can I pull out pairs of. So when you're thinking about how many pairs are going to come out for the x and for the y, you have to think about that they're both odd numbers. So you're going to at least have 1 pair that stays inside the radical. So if we have x to the 5th, how many pairs is in 5? Well, you know 2 pairs is in 5, so we can bring that out. So we would bring that out and we would put that on the outside. So there's 2 pairs in 5, so we put 3, so x to the second power. And again, if we had x times x times x times x, you have those 2 pairs, and then you have 1 left over. So inside the radical, you would put an x. So how many pairs is in 7? You'd have 3 pairs. So same thing, y times y times y times y times y times y times y, you have 3 pairs. And then you have the y left over. So we put y to the 3rd power on the outside because we have 3 pairs. Okay, and you cannot forget to take the 6 and multiply the 6 by the coefficient on the outside as well. So 6 times 3 is going to give you 18. So you have 18x squared, y to the 3rd power. And then in your radical you'll have 5x y, because that is what's left over. So that's the most simplified version. And you know this because you can't pull anything else out.